Everyone, we're going to start looking a little bit more at circuits today, how they're set up and some things we could do with them. Um, but just really some basics. So get that simulation open, the one we've been using a few times. And what I want you to do is I want you to recreate this circuit that I have pictured right here. Now, that circuit has a 9-volt battery, a 10 ohm resistor, and a 5 ohm resistor. It looks really complicated to make, but I'll just kind of show you really quickly. It's not too bad. I don't want this. I want this right here. All right. So a few things. Here's your battery. You can just grab these from here on the side and put them in, and you could turn them however you want. I'm gonna get rid of that one for now, though. I chose conventional current. That's why I have the arrows. Don't use electrons. We do conventional current, the flow of positive charge. Resistors are right here, and wires are right here. These things that measure current, remember from last class or a couple classes ago, those are called ammeters. Where do you get those ammeters? They're over here on the side. I actually used as many as I could. But if you notice off to the side next to the voltmeter, there's an ammeter, okay? So you can just grab those and bring them over. You have to put them in the circuit. The important thing about ammeters is they measure current, so the current has to go through them. So you basically just treat them like wires. That's really all it is. There's no resistance in them, just like wires have very little to no resistance. That's really what you're going to be doing here. So the first question I ask you is, how do you know which one of these two resistors? This is what a resistor looks like. Basically, resistors just slow current down. Light bulbs are resistors that light up. Regular resistors, these just slow current down. Sometimes you hook them up in circuits when you don't want as much current going somewhere. So that's what resistors are for. So one of these resistors is a 5 ohm and one is a 10 ohm. Now, I'll tell you right now, I mean, you could already see, this is the 5 ohm, this is the 10 ohm, all right? But how could you tell, if I didn't tell you, how could you tell that that one on the right is the 5 ohm resistor? Remember, current takes the path of least resistance, right? So notice how we have 2.7, let me see, I don't know if I have like a power, well, if I can point to anything on here. But I guess we'll do that on the other page. Let me just do that real quick. All right, so right here we have 2.7 amps coming out of the battery, and then the current splits. 1.8 amps goes to the right, 0.9 amps goes down. That 1.8 amps goes down this way through here and is still 1.8 amps here. That 0.9 amps goes down this way, and they recombine over here at point C to make 2.7 amps. So how do you know that that one on the right is the 5 ohm resistor? Remember, again, like I just said, current takes the path of least resistance, right? So I kind of skipped number 2. We'll get back to that in a second. The resistor on the right has less resistance, so more current. Remember, our symbol for current is I. All right. We skip number 2. It says, explain what you notice with the current going into and out of the junctions, or out of a junction, like at points B and C. So what do you notice about the current right here? So it's 2.7 going into the junction, 0.9 goes this way, 1.8 goes that way. And notice how 0.9 coming here, 1.8 coming here, and then we have 2.7 going there, okay? So hopefully you're saying something like they all add up to the same number or something like that, right? So this is a really important idea, and this is what we call the junction rule. All right, so current into a junction equals current out of a junction. Okay, so for example, at this junction here, current comes out of the battery, makes a right, it's going this way. 2.7 amps goes into this junction here, that little knob. Now 2.7 amps has to come out as well. 0.9 of it goes this way, 1.8 goes that way. Hopefully you see that 1.8 and 0.9 add up to be 2.7. That 0.9 continues down all the way to here, and that 1.8 continues down all the way to here. So again, right here, we have 0.9. Right here, we have 1.8. Those then recombine to be 2.7. Okay? So the current going in this case, is a total of 2.7. Current going out, total of 2.7. All right? So that's our junction rule. It sounds really simple, and it's really good when you visualize it. I highly encourage you, again, to create this circuit on your own. Being able to make these circuits, just building them, you start to get a better feel for how different things change the circuit, how changing resistance affects the circuit, how, changing the voltage, if you want to play with that on the battery, changes the circuit. All right? Now it says, write down an explanation for the current as it travels from points A to B to C to D. All right, so where's point A? Point A is right after the current leaves the battery, right? So I'll just start by saying 2.7 amps leave the battery. Then, so 2.7 amps leaves the battery. Now, we get to junction B. All right, so junction B, it looks like to me, at B, well, actually, it's kind of implied at B. At B, 1.8 amps goes to the right, I guess I'll say, and 0.9 amps go down. All right, do you see how that happened there? How we had 1.8 amps going to the right and 0.9 going down. All right? So then we have to get to resistor C. So we still have the 1.8 goes all the way down to here, and the 0.9 goes to there. So you could say something like the 0.9 amps and the 1.8 amps recombine. They went their own ways, now they recombined to become 2.7 amps again. And that 2.7 amps returns to the battery. Now we're going to start talking a little bit more about voltage drops and stuff in a couple classes, but it's really important that the current going into the battery is the same as the current going out of the battery. Okay? Same with any single resistor. So like the current on this side of the resistor has to be equal to the current on that side of the resistor. Okay, it's not going to magically lose current. At junctions, that's where current changes. But on this side of the battery, we have to have 2.7 amps, so we have 2.7 there as well. All right, so find the reading of the ammeter in the two images below. Okay, so you're going to be using the junction rule. So remember, current in equals current out. Okay, so I in equals I out. So how much current is going into the circuit? Let's see. We have 5 amps going in. And we have, we have another 7 amps going in as well, right? So we have 7 amps going in. And we have 3 amps going out. Okay? So this side has 12 amps. This side has 3 amps. So how can we get this equal? Well, we have to add 9 amps out, right? We have to add 9 amps to the outside. Okay? If there's a deficiency on the inside on the left, then we'd add the 9 amps there. So we know this is going to be 9 amps out. Going this way. All right, let's see. So it looks like 12 amps enter. And a total of 12 amps leave. 3 going to the right, 9 going down. All right. Now let's look at this one. How much is going in? How much is going out? It looks like, we'll count the in first. I see 5 amps going in. And I see a total of 7 amps out. So I need another 2 amps in for this to be equal. So this has to be 2 amps in. Okay, I'm not going to write inward because the arrow is pointing inward. Okay, so it's basically just like a little puzzle. See how much current is going in, see how much is going out, and then figure out what does the ammeter have to read to make sure that current in equals current out. Now if I look at my work, let's see, I have 2 amps. I might need to erase that. I have 2 amps, 2 amps, 3 amps in, so I have a total of 7 amps going in. 2 amps, 1 amp, 4 amps, a total of 7 amps going out. So sounds like we're pretty good. So that's the junction rule. It's as simple as that. I think this diagram here does a really good job of just kind of showing it in action and what it actually looks like in a circuit. So I strongly encourage you to make that diagram on your own. So I'm just going to talk really quickly about how ammeters and voltmeters should be placed appropriately. All right. So an ammeter measures current. So they must be placed so that the current you want to measure goes through them. That's how we place these ammeters. The current is set up, it's set up so that the current has to flow through them. If I get rid of this ammeter, there's no more circuit. Current can't make that jump. So you have to make it so the current must go through them. All right. Ammeters must be placed in series with the object they are measuring the current of. So, for example, let's say I have a battery. Let's do circuit schematics real quick. Here's my battery. Negative, positive. And then here's a resistor. All right. So the ammeter must be set up in series with it. So I could put the ammeter. I should have done that in multiple strokes, so it didn't just erase the whole thing. Okay. So the ammeter can be placed up here if I want. Okay, that's one place I could place it. Notice how the current has to go through the ammeter. So that's one way I could do it. I could also, instead of placing the ammeter there, I could place the ammeter down here. That's fine too. It forces the current to go through it. I could place, if I really wanted to, get rid of that ammeter. I could place the ammeter over here if I wanted to, before or after the resistor. Either one of those is fine. All right. Now here's an incorrect way to place an ammeter. All right, so here's my battery again. So there's this other way you can set up called in parallel, which we've mentioned before. Now this is wrong. Okay, here's why this is wrong. Current goes this way, it's coming through. Current goes down this way, does not go through the ammeter at all. Okay, so the ammeter does not measure the current through the resistor by any means. And actually, this is a short circuit because an ammeter is basically just like a wire that measures, think of it as a wire that measures current. There's no resistance over here, no resistance, R equals 0. So if you were to do this, all the current would go this way, actually. You get very little to no current going here. Okay? So this is a short circuit. So basically, rule of thumb for the ammeter, place it in line with whatever you want to measure the current of. Okay? If I want to measure the current through the battery, I put it right in there, right by the battery, right there. If I want to measure the current of the resistor, right there. You know, whatever, just in line with it, right before it or right after it. Now, voltmeters are the exact opposite. Voltmeters, as you probably guessed, measure voltage. But more specifically, they measure what we call the voltage drop. We'll get more into that later. But basically, some objects in a circuit use more voltage than others. For example, if you have like 3 batteries in series and a 12-volt battery, or excuse me, if you have 3 light bulbs in series and a 12-volt battery, each one of those light bulbs is going to have 4 volts being used, or is going to use 4 volts. Okay, in parallel is another story, but I don't want to get into that right now. But basically, they measure how much voltage that object uses. All right, that's all I have to think about. So, voltmeters do not let current run through them. Therefore, placing a voltmeter in series with an object will effectively stop the flow of current. All right. So here's the correct way. Oh, excuse me, let me write this. Voltmeters must be placed in parallel with the object you want to measure the current of. So for example, here's my battery. All right, and a voltmeter is what's going to be placed like this. Okay, That's how you would set up a voltmeter. And actually, let me just erase that real quick. The reason you set it up this way is because current can't go down this path. The current sees this V, that voltmeter, as like a broken circuit. So current can't go this way. So you don't have to worry about a short circuit in that case. All the current's just going to go this way. And you're just going to get a nice voltage reading. In this case, since there's only one object in the circuit, the voltage reading is going to be the same as the voltage of the battery, because that resistor is going to use all the voltage. Again, not really something we need to worry about right now. Here's the incorrect way to set up a voltmeter. Okay, in this case, that voltmeter is viewed as a hole in the circuit or an open circuit. Current can't get through it. That's not how voltmeters work. Okay, so you'll never set up a voltmeter like that. So let's look at this picture here. This picture here says, which circuit diagram below correctly shows the connection of an ammeter and a voltmeter to measure the current through and the potential difference of the resistor R. So let's look at this one here. Is the ammeter set up correctly? No, it is not. It's not set up in line with it. It's set up in parallel to the resistor. So that's not set up right. Is the voltmeter set up right? Yeah, actually the voltmeter is set up right. So the voltmeter part's right. It's in parallel. Voltmeters are supposed to be in parallel. All right, let's check out this one. Is the ammeter set up in series? Let's see. Current goes around. Yeah, the ammeter is just fine. So there's no problem there. But the voltmeter is set up in series with the resistor. That's a problem. Current can't get through a voltmeter. Okay, voltmeters have to be set up in parallel. All right, let's check out this one here. So let's follow the current through the circuit. So the current in the circuit's going to go this way, through the resistor and back. It can't go down this branch because this is basically a hole. We can't go that way. So this one's completely useless for a couple of reasons. Well, the voltmeter is actually set up just fine. The voltmeter is set up in parallel, but the ammeter is also set up in parallel and off the side. It's just not going to work. That ammeter is not going to read anything. So this one's okay with its setup, but this one is not right with its setup. Now let's talk about this one for a moment. Okay, this is the correct one. So let's see, is the voltmeter set up in parallel? Yes, it is. Okay. Is the ammeter set up in series? Well, let's see. Current comes out of here, goes this way, goes up through there, and it looks like the current has to go through the ammeter, the same current that went through the resistor, so this is good, right? And this one here, in which circuit represented below are meters properly connected to measure the current through resistor 1 and the potential difference or voltage across resistor 2. Actually, let me throw that in here. So voltmeters also measure voltage or potential difference. Same thing. Difference. All right. So basically, to see which ones are set up correctly. So we want the current through resistor 1 and the voltage across resistor 2. Okay, so let's focus on resistor 2 to start. Is this voltmeter measuring the resistance appropriately resistor 2? No, it's not. Okay. The reason being, it's set up in series with resistor 2. Is the ammeter measuring the correct current of resistor 1? Yes, it is. Set up in series. Is this ammeter measuring the current through resistor 1? No, this is actually a short circuit. This is set up in parallel. That's bad. It needs to be set up in series. It should be placed right here. That would be a good spot to put it. And this one is placed appropriately. The voltmeter is set up in parallel to resistor 2. These are both set up in parallel, so this one's right. But again, this has to be set up in series. So this should be set up like ideally over here. All right. And let's look at this last one. It's the only one that's left. So it looks like this one, the ammeter is set up in series with resistor 1 in the same line as it. So that's good. And it looks like the voltmeter is set up in parallel with resistor 2. So that's good there. All right. By the way, just to talk about this one, where should it be? This should not be here. If you were doing this right, it would be right here. Okay. And this, like I said, it should be over here if you were doing it correctly. All right. So I know this is like brand new to most of you, but go through it again if you're a little bit confused. Just to show you and I forgot to show you before, what a voltmeter looks like in a circuit. Here's just like a classic circuit for you. I'm going to clear this whole page really quickly. I don't know if there's an option to clear the page. I think I just go to that. Here's my battery. Here's that. We have wires. We have a resistor. We're going to do this a little bit quicker. And we have more wires, and we're going to finish the circuit. There it is. There's our circuit. So where we would put an ammeter would actually be, it doesn't really matter. You put it like right next to it. You don't need a wire connecting it to it. You can connect it directly there. All right, so here's my ammeter set up correctly. It's in a nice series. It's in series with the resistor. Here's my voltmeter. What I do is I take the voltmeter and I connect it to either side of this. Okay? In that case, it tells me it's 9 volts. All right, so the voltmeter is kind of like coming in from the outside of the circuit, just testing what the voltage is. All right? You can't run current through this thing. All right, it just doesn't work. Just to show you what it looks like if I were to set up the ammeter in parallel. All right, so we'll close that and we'll just create another branch parallel to this. Just connect that right there. Notice how we get a short circuit because there's no resistance. Basically, the ammeter acts like a wire that measures current. So there's just way too much current going over there because there's no resistance in that path. All right. So check out the Google form. There's some questions at the end. Feel free to stop into extra help at 3:15. We can go through it. I can answer any questions if you're really struggling to understand this, because I know it's a brand new topic to most of you. You never really worked with circuits or circuit diagrams before. All right.